Okay, guys, for this review, we are going to go over linear models. We're going to go over linear models in slope-intercept form as story graphs, scatter plots, and two-way tables. Remember to pause the video at any point you need to pause in order to take notes. So let's refresh our memory on our linear model as an equation. We will write a linear model in slope-intercept form in the form of y equals mx plus b, where m is your slope and b is your y-intercept. Now let's recall the slope is the change between 2 points on a line. It is the change of the y values compared to the change of the x values. We use m to represent slope, so it's the change of the y's or the rise compared to the run. The formula, when given 2 points, is y2 minus y1 over x2 minus x1. So as long as you know 2 points of a linear function, you can find the slope or the constant rate of change. Recall that the b value, our y-intercept, is when x is 0. So anytime you have an ordered pair where x is 0, that is where that graph crosses the y-axis, which is the vertical axis. Sometimes the b is also called the initial value or your starting value. This is super important when we're taking a look at word problems. So here we have a linear function. This is a graph of someone's savings. We can see as weeks go by, the total savings increase. So we want to know how much money did this individual start out with, and then we want to know how much did they save each week. So our x, and we can see on our x-axis, represents weeks of saving. We know the y value represents the total amount saved, so total savings. It's always important to know what your x, your input represents, and your output represents. The output usually is the total of whatever you're talking about in the situation. So we can see that our x-axis is going up by 2s, but in between it's going up by 1. So I like to go ahead and write in those missing values to make it easier to find the slope. Now, if we can't find the slope easily, we can always use 2 points. Also, on our vertical axis, this is the total money. We're going up by 100s, but in between we're going up by 50s. So I'm going to go ahead and jot that in as well. So we can see that this individual started with $50. So our B value is 50, or writing it as an ordered pair 0, 50. Then we can see from this point to this point, we can see a nice rate of change. I like to look at values that come on the corners of each of these axes. So we can see that we're going up 50. So my slope is going up 50. So rise over run, and then the run is 2. So this simplifies to 25. So altogether, our equation, our linear model to represent the total amount savings is y, total amount. We're going to save 25 per week plus the initial amount of $50. Now let's pretend we couldn't find the slope so easily. Let's use the formula. So when you're using the formula, you can use any 2 points on the graph. So I'm going to use 2, 100, and then 4, 150. So slope is going to be y2, the second y value, 150, minus y1 over 4 minus 2. This gives us 50 over 2, which confirms our slope of 25. Now, you can use your linear model, your equation, to make predictions. Let's see how much money this individual will have for when they save for, let's say, 20 weeks. So we're going to plug in 20 for X because that stands for weeks. And then we're going to use order of operations. So 25 times 20. So 2 times 25 is 50 plus the 0. And then don't forget the initial amount. So the total amount in 20 weeks, if I write this as order pair, is going to be 550. Now let's say that they have a total savings of 800. So the total is 800. We want to know how many weeks. So we're given the total 800, and we're looking for how many weeks is it going to take for that individual to save that much money. So we're going to solve for X. So we subtract 50 from both sides. And then we're going to divide each side by 25. And X, number of weeks, is going to be 30. So in 30 weeks, this individual is going to have $800. Okay, let's take a look at another example. Here we have a graph, and we can see the graph is negative, so it's going to have a negative slope. It's the number of soda cans in a machine. And our x-axis represents days. So I'm going to write in those missing numbers. And then our number of soda cans, we can see the maximum amount of soda cans is 500. So the initial amount of soda cans when filled is 500. So this is our initial value. Now the slope is going to be negative. Let's identify what X and Y are. X is the number of days, and Y. Now make sure you're specific. It's the total cans in the machine. It's not how many have been extracted. It's the total amount of soda cans in the machine. So we're starting out with 500, and then it's going to go down each day. So let's see how many soda cans there are per day. Let's find a slope. So I can see this is not easily seen. So I'm going to find 2 nice points. So I'm going to start out with my y-intercept. So that's going to be 0, 500. And then it looks like this is a nice point that comes in on the corners of 15, 200. So now we're going to use our slope formula. So we have 200 minus 500 and then 15 minus 0. So we're going to have negative 300 over 15. And we can see we have a negative constant rate of change. So now we have a negative, when we simplify this, negative 20. So our slope is negative 20. This means each day the number of soda cans in the machine goes down by 20. So my equation is y equals negative 20 times x, number of days, plus the initial amount of 500. So let's see how many cans there will be on day 21. So we're going to plug in 21 and see the total amount of cans left in the vending machine. So we're going to multiply 20 times 21, which gives us negative 420 plus 500. So the total amount of cans in 21 days is going to be 80. Now, let's see how many days it's going to take when we have a total of 0 cans in the vending machine. So instead of the y-intercept, which is the total amount of cans on day 0, we're going to see how many days until our vending machine has 0 cans. So we're going to plug in 0 for y. And we're going to solve for x. We're going to subtract out 500 and divide both sides by negative 20. Let's bring this up here. So we have negative 500 equals negative 20 times x. Let's divide by 20. And the total amount of days, we're looking for days, the total number of days that it is going to take to empty the machine is going to be 25. So on this day, about right here, if this is 25 and that's 26 and that's 27, we can see and predict our line will hit the x-axis.